day, grade 12 learners. Welcome to today's mathematics lesson. My name is Tepang Mapotani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12, in today's lesson, we are focusing our attention to paper 2 revision as we are preparing for our final examinations. Now, for this lesson, grade 12, we are going to focus on the topic of statistics, and we are also going to focus on the topic of analytical geometry. Now, grade 12, by the end of this lesson, you must be able to identify the structure for paper 2, and we are going to focus on the topic of statistics, and we also focus on the topic of analytical geometry. Now, grade 12, this is the structure for paper 2, and we know that our paper 2 has 4 topics. And for this lesson, we are going to focus on the first 2 topics that are highlighted in red them. So that is statistics. The topic of statistics weighs 17% of our paper 2, and it is allocated around 20 marks, and it is found in question 1 and question 2. And the second topic that we are focusing on for this lesson, it is going to be analytical geometry. This topic weighs 17% of our paper 2. It is allocated around 40 marks, and it is found in question 3 and question 4. Now, grade 12, this is our information sheet. So from our information sheet, this is the information that we're going to find from there. And we can now see that one of the formulae that we're going to utilize is the one on finding our gradient, and the one finding at the gradient using an angle, and application of that, which is analytical geometry, where we are working with circles, and we are going to work with all of these formulas as we are looking at our paper 2. Right, but for this topic or for this lesson, our main focus will be on those 3 topics that I've had, those formulas that I've highlighted. Maybe we can also include some of these formulae, but the main ones we're going to use are those that I've highlighted there. Right. Now, grade 12, let us go through our checklist. Remember, when we are utilizing our checklist, this is a checklist that we utilize to do what? To check concepts, to verify the mastery of certain concepts, to say, as I am going into my examination, do I have all of the concepts that are required for me to pass a certain or a particular topic in my paper? Right. So for paper 2, we are focusing on statistics for this lesson, and we are now saying the first key concept that we must focus on is histogram and frequency polygons. To say, for these ones, you must be able to draw and interpret those histogram and frequency polygons. Number 2, you must be able to differentiate between a histogram and a bar graph. So if you have acquired those knowledge, or we have those concepts mastered, then we can tick there and say, okay, for my paper 2, when I'm going to my examination, I have this covered. Working with the same leaf, to say, am I able to draw and interpret, identify the mode, calculating the median using the same leaf. Number 3, and grouped data, am I able to make use of a calculator? Very important. We need to work with the calculator when we're dealing with statistics, so it makes a job easier for us and manageable. And some of the concepts that we're going to focus on, they really need the utilization of a calculator. So make sure the calculator, as part of your book work, it is actually done to the core. Right. Number 2, are we able to work with the measures of central tendency, where we are looking at the mean, mode, and median when we are given an ungrouped data? Number 3, are we able to find the measures of dispersion, range, quartiles, percentiles, calculating the interval and identifying where the outlier lies? We're working with the outliers also. Number 4, when I'm working with the grouped data, grade 12, I need to verify that I can find my estimated mean, because remember, when we are looking at the grouped data, we are working with the estimates. So now we're going to look at what we call an estimated mean, right? So ungrouped data, we're just calculating the actual mean. Here we are going to estimate the mean, right? Because our data is going to be grouped, so we're not given individual data points, right? Are we able to find the model class as we know that the group data is mostly arranged in the intervals. Am I able to find the interval where the median lies? Am I able to find our quartiles where we are looking at Q1, which is the lower quartile, Q2, a median, and Q3, which is an upper quartile? Number 5, am I able to find the variance standard deviation of the grouped and ungrouped data? And remember here, this is where the calculator state mode instructions are very, very crucial and are very important for me to know and be able to utilize those to find my variance and the standard deviation. Number 5, and then bullet point number 2 from 5, we are saying, am I able to find the spread of the data? Then we're looking for examples where we're looking at points that are lying within 1 standard deviation or 1 standard deviation of the mean or 2 standard deviation or 3 and so on. Right, let's proceed. Number 6, am I able to find the 5-number summary and utilize that 5-number summary to represent or draw a box and whisker to say that 5-number summary constitutes minimum, maximum, lower quartile, which is Q1, median, Q2, and upper quartile, which is Q3. And we are now saying utilize this 5-number summary to draw the box and whisker diagrams. Number 7, we are saying, am I able to now work with the skewness of the data to say, am I able to interpret the box and whisker and frequency polygons and see and be able to identify how is the data skewed? Right. Second bullet point, we are saying we are going to also look at the skewness of the data to say, is my data positively, negatively skewed, or it is symmetrical? And are we saying again, when we're looking at the skewness of the data, can I find the skewness of the data using the graph and or using the mean and median? So remember, you can use mean and median to find how data is skewed. When mean is greater than median, how is the data skewed? When mean is less than the median, how is the data skewed? Then number 8, am I able to work with the OGAF curves to say, am I able to sketch and interpret the OGAF curves? Am I able to calculate the specific values using the OGAF curve? The example, can I be able to find the median? Can I be able to find the lower quartile, median, and the upper quartile? So we must be able to find those 3 using the OGAF curve. Number 9, for statistics, again, we are also required to work with what we call a bivariate data. And for bivariate data, in most cases, we are going to start by working around our scatter plot. So when we're working with that scatter plot, we are saying we are able to identify the outliers using that scatter plot. And we must be able to draw and interpret a scatter plot. So you must be given data points that you need to represent and draw on a scatter plot and interpret that scatter plot in this case, or you might be given a scatter plot and you must interpret that scatter plot. So you must be able to draw and interpret the scatter plot. Number 10, am I able to now draw the least squares regression line? So when you're dealing with the least squares regression line, the first thing that we're going to look at is the use of a calculator to determine the equation of the regression. And remember, our equation of the regression line will be y is equals to, with that head to show that we're working with the estimate, it's equals to a plus px. And however, this formula, remember, it is found in our formula sheet. And are we able to sketch this regression line on our scatter plot? Number 11, we must be able to, when you're dealing with the bivariate data, find the correlation of coefficient and interpolation and extrapolation to say, where with the correlation of coefficient, be able to interpolate and extrapolate, use a calculator, and be able to explain the association between the data to say, between my 2 variables, mostly we're going to look at x and y. I must be able to use a calculator and find a correlation coefficient, which is r, and I must be able to use that correlation coefficient of r to explain how or the relationship between my variable, which is x and y. How are they relating? Are they having a positive correlation, negative correlation? Is it strong? Is it weak? And what so forth. And I must be able to work around the prediction. When I'm working around the prediction, that's where we are going to work with interpolation and extrapolation, right? And this prediction, remember, it is going to be used in conjunction with our least squares regression line. Right, great works. Now, without any further ado, let's now proceed to question 1 from November 2024. So we are going to look at paper 2, which is we're going to start with this question 1. And for this question, remember, I will start by giving you at least 2 or 3 minutes to take down the information there. So I'm going to give you only 2 minutes to take down the information, the statement, interpret the statement, then go through the points there, write them down, and try to draw the rough scatter plot there. Right. So for that, I'm giving you 2 minutes. Then I'm gonna proceed and go into questions. So you have 2 minutes start now. Welcome back, graduates. Now let me just go, or let us go to our questions. So we have question 1.1 until 1.5. And for these questions, I will give you only 6 minutes to complete these activities, and you have 6 minutes start now. Welcome back, grade 12. Now, let us now dive deep into our solutions. Before we do that, I will go back to the statement and we'll go and read the statement together. At the beginning of a season, the coach of a junior boys rugby team recorded the weight in kg. So, right, so this is what we did. We recorded the weight in kg of the 15 players of each. So this is very important. So the number of players, there are 15 in his team, and the number of push-ups that each player, so we're looking at the weight and the number of push-ups, will be able to do in 1 minute. The data is represented in the table and the scatter plot above. The least squares regression line for the data is also drawn. So we can see that we have weight in terms of X, and we have number of push-ups per minute in terms of Y. Then we have the scatter plot that is drawn for us. We can see that push-ups are represented in X and weight is in Y, and we can see that we have a scatter plot that is drawn here. Right. Now let us go into our question. Now question 1.1, it reads as follows. Determine the equation of the least square regression line of the data. To find this equation, remember, we must use the calculator instructions. When we do so, we know that our least square regression line is represented by y equals to a plus bx. And remember, this is represented, or this is found in our information sheet. Right. Then the value of a, when we utilize that state mode calculator, we get it as 39,456. Then our b, it is equals to negative 0,5900, and just those to show that it is proceeding. Then we can substitute those values of a and b in our regression line. We get our equation as y is equals to 39,46 minus, remember our b there, so this is where a is. Our a was 39,46 plus negative b, so our b is going to be negative. So it's going to be negative 0,59. So that's why we have a negative there. It's just, it was y equals to a, y is equals to a, which was 39,46 plus negative 0,59 x, which is now, this was our b. Then the negative and the positive have multiplied. That's why we're having a negative there in the middle. So that is our least square regression line. So we're going to get a mark for a and b and the whole equation being correct. Right. Number 1.2, it reads as follows. Write down the correlation coefficient. To find the correlation coefficient, remember, group 12, we utilize the state mode. Then our correlation coefficient, when we use the state mode, it is going to be negative 0,8. And remember, when you find this correlation already, you must be thinking of the interpretation to say, oh, okay, it's negative. And remember, our R, it is found between negative 1 and positive 1. So our R is found between positive 1 and negative 1. Remember, when we're closer to the negative 1, we have a strong negative correlation. You can see that the negative 0,8 it is closer to -1. So you have a strong negative correlation. Let's proceed and go to our 1.3. 1.3 reads as follows. The coach uses the least square regression line to set the target for the minimum number of push-ups each team member according to their weight. Right. Number of push-ups by each team member according to their weight. Predict the number of push-ups that a team member who weighs 29 kg should be able to meet the target. So what's important when we are now working with prediction is the following. We just need to know, what am I given in my question statement? Am I given the X or the Y? So we are given the weight. The weight they said is 29 kg. What is my weight? My weight in this case, it is my X. So it's represented by X right there on my scatter plot. And I know that my X now is given as 29. Now, we need to predict the number of push-ups. The number of push-ups, remember, it is represented by Y. So we are looking for Y when we are given the X. Now, to find that Y, we're going to use our least squares regression line equation. Then I'm going to substitute X equals to 29. Then I get my Y, which is 22,35. So a person who's weighing 29 kg should be able to, we can predict their number of push-ups to be around 22 to 23. Right. Let's proceed to 1.4. Now 1.4, it says write down the mean number of push-ups for the given data. So what are we looking for? The mean. But for what? For number of push-ups, we need to be very, very vigilant here. So we are looking for the mean number of push-ups. In most cases, the mean number we're working with, it was X bar, which is the one for weight. But in this case, they're looking for the one of push-ups. The one for the push-ups, it is going to be our Y bar. And remember, we're using the state mode to find this mean number of push-ups. Then we're going to now say from our calculator, our mean number of push-ups is going to be 18,33. So be clear to find the one for Y, because the one that we're looking for, it is for the push-ups. And the push-ups are, it is found on our Y. So this was a very nice, interesting question. Right. Now, grade 12, let us move on to question 1.5. And for this question 1.5, grade 12, I will give you only 3 minutes to complete 1.5. And your 3 minutes starts now. Welcome back, grade 12. Let us look at 1.5. 1.5 reads as follows. The players trained hard during the session. At the end of the session, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the session. Okay? How does this increase in the number of push-ups influence the standard deviation of the data? Now, let's look at this one. Remember, when they told us from our information that, let's look at our scatter plot. Let's say the scatter plot, it looked like this. I'm just going to draw that scatter plot right there. And let's say with that scatter plot of mine, I'm just going to say maybe this point, it is my mean value in that case in terms of Y. Right. So we are told that each player was able to do 5 more push-ups per minute. When they're saying each player was able to do 5 more push-ups, that means we are saying from every point that we're having on a scatter plot, in terms of the number of push-ups, which is the Y, is going to increase by 5. So these values will all increase by 5. So they'll shoot up by 5, all of them, because all of these players were able to do 5 more push-ups. Right. So we can see now that our mean, or all of these points, will increase with 5 more. So if I were to draw maybe a new scatter plot, so the old scatter plot, let's say it was here. So the new scatter plot, with every point going 5 points up, it is going to maybe be around here. Even this mean value, which is our Y bar, from here maybe at the bottom, it will also shoot 5 units up, going up in that case. So that is what we are looking at for this question, to say, okay, so if the players are able to do 5 more push-ups, it means each point is shooting 5 units up more. Now let's continue and read our question. The question says, how does the increase in the number of push-ups influence the standard deviation of the data? Now, let us look at and remember what is the standard deviation. Standard deviation, we are just looking at how far are the points, or how far are the points moving, or how far are they from our mean value. How far the points are from our mean value. In simple terms, how spread out are these points are from our mean value. So they are spread out, so you can see that is the distance. Then you can see that they are here, they were here, they were here in that case. So that is standard deviation. That's what it studies. It studies how spread out. So this is why we are looking at the measures of dispersion. That's why the standard deviation is measures of dispersion, because we're just checking how dispersed are these points from our mean value in the case. So we can now see that is what standard deviation measure. So when we are doing 5 more push-ups, what is going to happen is the following. The very same points are going to move with that mean value. Remember that, right? So all of these points are moving with 5 more, all of them. So what is going to happen is that the whole scenario there, all of these points are still going to be spread out from the mean with the same value that we had right here. So the standard deviation won't change because all of these points are shifting up. Even the mean point is shifting up. So the distance to the, or the spread to the mean value, it is still going to be the same. So that is what we are going to say in this case. So our standard deviation won't be affected. So our answer is going to say the increase in number of push-up will have no influence on the standard deviation, and we are going to say the standard deviation will now remain the same. So that is what's going to happen here. Remember, standard deviation, how spread out are the points from the mean value. And we can see when we are adding 5 more push-ups, even the mean value will increase by 5. All the points will increase by 5, but they won't be more spread out from the mean value again, because everything is increasing by the same value, including the mean point. So that's why we are saying the standard deviation will remain the same. Now, the 12, let us proceed to 1.6. So 1.6, the 12, I will give you 3 minutes again to complete 1.6, and your 3 minutes start now. Welcome back to 12. Now let us look at 1.6. 1.6 reads as follows. At the beginning of the session, the coach used the least square regression line as the minimum target for the player to aim for. Determine the maximum possible increase of number of push-ups that the member must obtain to reach the minimum target. Let's go and go into this question. Let us read and understand this question. What does it say to us? It says to us, at the beginning of the season, the coach used the least square regression line as the minimum target for the player to aim for. So meaning, each and every player, if, for example, the player who's weighing 30 was able to do 15, 16, 17 push-ups. So how many more push-ups should this player make in order to reach the target? So this player, when they weigh 30, their target, we just take that 30 to our least square regression line. So our target in this case is going to be, for example, it is going to be 21, 22. So it's going to be 22. So this one has to move from 17 to how much? To 22. So that is what is actually happening here. It says each and every point that we're having on our scatter plot must be the minimum that they must meet. It is going to be what? It is going to be around that least square regression line in that case. So that's what we are saying for this one. So the minimum target, it is to say, it is represented by the regression line to say our minimum is regression line. So each and every point must be around the regression line. So this was really the problem because they've already passed the minimum. But those that are below, how much more push-up or how many more push-ups must they make? Like for example, I made an example, the one weighing 30 to 7. If you're weighing 30, you are making 17. The coach says to you, your minimum target, is, according to your weight, it must be around 22. So you must move from that 17 to 22. So you must make to how many? 5 more push-ups per minute. So that's what we are saying here. So this question says Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. So we are looking at the maximum increase to say this one increased by 5. So the maximum one is the one that is far from the target. So our target here, remember, it is going to be what? It's our regression line. So if you look at this player who's weighing 40, the one weighing 40 was able to do 6 push-ups. Right, so we must check this one now. So the person who was weighing 40, that was able to make around 6 push-ups, must move from that 6 push-up, must go until the regression line. So we just need to know how much is that increase. So it is from that 6 to how many? To 15, 16. To what? To 16. Right. So the maximum increase that we're going to have, the point that is furthest from the regression line, or the lowest from the regression line, it is going to be what? It's going to be the point here, which is the one weighing 40. Is the one of 40 is to 6. So we are now saying 6 is the furthest y value below the regression line. So the 6 is the furthest from the regression line in this case. So there's an increase of 10 push-ups. So there's an increase of 10 push-ups that will get the team member to 40 and 16, which is the minimum number of push-ups weighing 40 kg. So we are saying to you, this one weighing 40, the minimum push-up that they must be able to make according to the standard set by coach must be on our regression line, which is 16. So we are going to say 16 minus 6. So the maximum possible increase, so the one that is going to have the highest increase, going to be 16 minus 6, which is 10. So there must be 10 more push-ups. So the maximum increase is going to be 10, so that we can meet the minimum number of push-ups according to the regression line target set by our coach. Right. So let's proceed to 12. I hope that makes sense. So we are going to proceed to question 2. So for question 2, we are having 2.1 until 2.3. And for these 3 questions, I'm giving you only 4 minutes to complete those 4 3 questions. So your 4 minutes starts now. Welcome back to Tutors. Let us look at question 2. Question 2 reads as follows. The cumulative frequency graph, which is okay, shows time taken in minutes for 60 employees to travel to work each morning. 2.1. Estimate the median of the travel time. To estimate the median, this is what we are going to do. We are going to find Q2 using the archive, and to do the first thing that we are doing, going to say Q2 equals to 1 over 2 multiplied by n. What is n? N is our total frequency. So our total frequency in this case is going to be how much? The highest point there is going to be 60. So this formula will help me find the position on the y-axis in this case. So to find the position on the y-axis, is going to say 1 over 2, our n is going to be 60. So 1 over 2 of 60 is 30. So the value is going to be 30. So the position on Qt is going to be 30. But remember, we are looking for the travel time, which is mean in this case. So we're going to just take the 30 and extend it until we meet our archive curve. Then we're going to drop down. As we drop down, it is found between 1, 2, the third and the fourth line there. So that is going to be how much? So this is going to be 60. This is going to be around 65 in that case. So it is around 65. So when you go there and you use our graph paper, because we're using a graph paper, so you must be able to get our accurate values in this case. So it is going to be 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, and 8. So we're going with the step of 2 in this case. So that one is found between 64 and 66. So between 64 and 66 is going to be 65. So that is going to be our median. Now to find our lower quartile in this case, so to find lower quartile, what are we going to say? We are going to say Q1 is equal to 1 over 4 of n. And remember, it's our, so we're looking for the position of Q1 on the y-axis. So n, remember, it's the total frequency, or our last value on the cumulative frequency there. So it's going to be 1 over 4 of 6 is 15. So we're going to locate 15 there. Then to find Q1, we're going to take 15 and extend it until we meet our OGAF. Then we drop down, there is going to be 14, 42, 44. So the Q1 is going to be here, which is 44. Right, 2.3. 2.3, we need to estimate the interquartile range. To find the interquartile range, in this case, we need what? Interquartile range, remember, IQR is equal to Q3 subtracting Q1. So we already found Q1 from 2.2. Now to find Q3, we are going to say Q3 is 3 over 4 into n. Our n is 60. So our Q3 position in the y-axis is going to be 45. So we're going to locate that 45 and we extend until we meet our graph, and we drop down. So it's going to be 82, 84. So Q3 is 84, and remember Q1 was 44 from the previous question. Then interquartile range will be Q3 minus Q1, which is 84 minus 44, which is 40. That is our interquartile range. Right, grade 12, let us proceed to 2.4. And for 2.4 grade 12, I will give you only, so you'll be given only 5 minutes to complete 2.4, and your 5 minutes starts now. Welcome back, grade 12. Let us look at 2.4. 2.4 is as follows. The minimum and the maximum times taken for an employee to travel to work are 5 and 120 minutes respectively. On the scaled line in the answer book, draw the box and whisker and indicate the distribution as represented in the OGAIV above. So what are we looking at here? So this is our scaled number line from our answer book. So I've given it to you there, so that when you're drawing that box and whisker, you are able to utilize that. So now let's go and find the box and whisker. Remember, to find the box and whisker, the first thing that we need to find is to find the minimum value, and our minimum value, it is going to be 5. So we're told that is 5 and 20, and the maximum value in this case, let's just proceed and find our maximum value. Our maximum value was 120, so they told us it's 5 and 120, and we can now see those two values from our OGAIV. So we can see the minimum value here is going to be 5. That is the minimum value, and the maximum value is going to be 20. So that is between 5 and 20 from our question. Then we know that minimum is 5. For Q1, we found it was 44. Q2 was 65. Q3 was 84. And maximum was 120. So just put all those values. So minimum is 5. So we put in the 5. So this is our mean. Q1 is 44. So that is the beginning of the box there. This is Q1, which is 44. Then Q2 is 65. This is Q2. And this is Q3. Our Q3, it is 84 in that case. Then the maximum value is going to be 120. So that's when you're going to get your 3 marks for the box and whisker. Right, let's proceed, graders. So we are going to proceed to 2.5. And for 2.5, I will give you 3 minutes to complete 2.5. Then your 3 minutes starts now. Welcome back, grade 12. Let us look at 2.5. 2.5 reads as follows. The company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. What percentage of employees will be able to work from home for part of the day? So we need to find the percentage of those people who are going to work from home. So now, what are we saying here? We are saying, let's read again. The company manager decides that all employees who travel for an hour or more, so those who travel for an hour or more, so we're going to go to our OGAIV curve. So our time in minutes, so our hour or more is going to be 60. Remember, 60 minutes, 1 hour. So So those employees is 22, 25, 26. So it's from that 26, right? So those who travel from an hour or more is from 26. So this is more than an hour. It's all of this is from 1 hour to 120 until the 60. Until 60, right? So we'll be able to work from home. So these ones that are here from 26 to 60 will be able to work from home. Then we want to know what is the percentage of employees that will be able to work from home in that case. So let's go in and look at our answer for this one. So we're going to say number of employees who qualify for more than 60 minutes. This is where we're going to say this is 26, and this is our maximum is 60. So this is from 60 minutes, which is 1 hour, until 120, which is the highest there. So this is the employees that we are looking at. So it's going to be 60 minus 26, which is 34, right? But we're looking for this in terms of percentage. We're going to say 34 divided by 6, which is total, multiplied by 100. And the percentage of employees that will be qualified to work from home, it is 56.67% of the employees. Now, grade 12, let us proceed to 2.6. And for 2.6, grade 12, I will give you 3 minutes to complete 2.6. And your 3 minutes starts now. Welcome back, grade 12. Let us look at 2.6. 2.6 reads as follows. Employees work 8 hours in a normal working day. The manager decided on the following rule for the time to work from home. An employee is allowed to work half an hour from home for each time interval of 20 minutes or part thereof, above an hour taken to travel to work. On a certain day, an employee takes 110 minutes to travel to work. Calculate the number of minutes that this employee will be able to work from home on this day's slide. This question needs us to interpret the statement properly and go through it again. Right, now let us interpret this statement and understand what does it mean actually. Let's interpret again. So it says employees work 8 hours in a normal working day. The manager decided on the following rule for the time to work from home. So we are focusing on those that are working from home, right? And remember, those who work from home, we must start by understanding here. First thing that we need to understand is the following. Those who work from home, this is how they are working, the ones that are from home. It is the one from 60 minutes and above. So the ones from 60 minutes and above are the ones that are working from home, right? An employee is allowed to work half an hour, is allowed to work for half an hour. So they're allowed to work 30 minutes. For each time they travel in an interval of 20 minutes, or for each time interval of 20 minutes. So this is what it means here. So those who travel for more than 60, if you travel for more than 60 minutes, let's say more than 60 plus 20, then when you get home, you'll only be allowed 20 for 30 minutes, for example, right? Or part of thereof above an hour taken to travel to work. So to say, from the 60 minutes, because we're traveling more than 60 minutes, if you travel an extra 20 minutes to get to home, so 60, our 60 plus 20, so plus 20 minutes, so we're going to have 80. So if you're traveling, remember already we're traveling for more than 60 minutes, so if you travel 20 minutes extra, you will be only able to work, or you'll be allowed to only work how many minutes? 30 minutes when you get home in this case, right? And we are going to now proceed with this type of information. Let's read again. An employee is allowed to work half an hour, so you'll only work 30 minutes when you are at home for each time interval of 20 minutes. To say, from the 1 hour you are traveling, for every extra 20 minutes, you'll only be allowed to work how many? 30 minutes in a day, right? Or part of thereof above an hour taken to travel to work. That is to say, it doesn't necessarily have to be 20 minutes. As long as it's 60 and maybe it's 65 minutes, for example, to get to home, then you'll only work 30 minutes. So it's just part of or thereof. So it doesn't have to be to the maximum of 20 minutes. As long as you are having from 60 an extra travel time from that 60, then you'll only be able to work 30 minutes. So if the extra travel time, I travel extra by 10 minutes, for example, then I will only work 30 minutes. So that's what that part of me. Now let's go and read the question now. The question says, on a certain day, an employee takes 110 minutes to travel to work. Calculate the number of minutes that this employee will be allowed to work from home on these days. Okay, this is very important. So it says on a certain day, an employee takes 110 minutes. So we need to know how many minutes will this person work. So let's proceed and go and apply this rule here. So we are saying 60 plus 20 is 80, and we are supposed to get to a goal of 110. So to get 110, we're going to add another 20 here, so that we can get an extra working time of 30. So extra working time of 30 minutes is when we added plus 20 minutes. So this is 30 minutes work. So this is 20 minutes travel. So this is travel, this is work. Right. Then we're going to now say 80 plus 20 minutes, we're going to have 100 minutes. So this is 100 minutes. Right. So let's proceed again. So we can now see that we haven't reached 110, we are at 100. So we're going to add 10 minutes to get 110. So this is where 110 is. So this is plus 10 minutes. But remember, they said or part thereof. So this means it doesn't have to be all 20 minutes. So even the 10 minutes, even if you travel 10 minutes extra there, we are going to work 30 minutes extra. Right. So that's what it means in that case. So how many minutes will this employee be able to work? So when we travel 110 minutes using this rule, we are going to work the 30 plus 30 plus 30. So it's going to be 30 plus 30 plus 30. So this employee will only work for how many minutes? 90 minutes. Or we can just work with this in terms of interval. So we have 1, 2, 3 of those intervals. So it's going to be how much? So we are going to look at a situation where we're going to have 3 times 18, which is just 90 in this case. Right. So let us just go through that solution then. So our solution is going to 3 intervals of 30, 18, or just 20, 20, and 10. Right. Then it's going to be 3 times 13. Time allowed to work from home is going to be 90 minutes. Right. Now, graders, we are now moving on to our topic of analytical geometry. So this is the subtopic. Let us now go through its checklist. Now let us check the concepts that we need for this topic. Number 1, we must be able to use the distance formula to determine the distance between 2 points. So the distance formula, remember, be able to locate that distance formula from our information sheet. Number 2, determining the coordinates of the midpoint of a line segment, or use the midpoint formula to determine another point. So working with the midpoint, we must be able to work with the midpoint. Again, this is in our formula sheet, the midpoint formula. We must be able to calculate the gradient between 2 points. So this formula again is there in our formula sheet. Understanding the relationship between the gradients of parallel lines, and using that relationship to perform calculations. So remember, parallel lines have the same gradient, so you must be able to work with that relationship in this case. Right, I think maybe let me just write down the formulas for us. So remember, the distance formula will be x1 subtracting x2 all squared plus y1 subtracting y2 all squared. Right, then the coordinates of the midpoint, remember the midpoint, it is going to be given x1 plus x2 over 2 is 2, y1 plus y2 over 2. Right, that is where we're looking at our midpoint. Then the gradient, remember, the gradient is going to be y2 minus y1 over x2 minus x1. Right. Then when we talk about the relationship between the gradient of the parallel lines, we are saying the gradient is the same. So the gradient of a line that are parallel are equal. So these are equal. And we must understand the relationship of the gradient of perpendicular lines, and using that relationship to perform calculations. Remember, the relationship of the perpendicular lines, we are saying the m of a line multiplying by m of another line which is perpendicular, the gradient must be equals to -1. Let's proceed. Number 6, you must understand the relationship of the gradient of the collinear points. So to understand that collinear points have the same gradient, meaning if I have 3 points on the same line, A, B, C. If I have the gradient of line AB, where I have coordinates of A and B, I find the gradient. That gradient is the same as the gradient of, so MAB will be equals to let's say for example, AC. So collinear points have the same gradient throughout. Determine the angle of inclination. So you must be able to find that angle of inclination. Remember, in most cases here, we are working with tan alpha, tan theta is equals to the gradient of that line, of that inclined line, or the line of that inclination. Then you must be able to determine the equation of a line segment. So here we're working with a straight line. So be able to find the equation of a line segment where y equals to mx plus c. You must be able to use the angle of inclination to calculate other angle in a geometric shape, a triangle or a quadrilateral. So we are going to find the angles that we are finding in our quadrilaterals. We must understand the properties of triangles as well as scalene, equilateral, right angle triangle, and using analytical methods to prove them. So you must be able to work with triangles and their properties and be able to prove those triangles. Right, let's proceed. Number 11, for analytical geometry, you must be able to understand the properties of quadrilaterals, parallelogram, rhombus, kite, square, and trapezium, and we're going to use analytical methods to prove them. You must be able to determine the equation of a circle centered at the origin. And remember, this one is the one that says x squared. It is x squared plus y squared is equals to 0. You must be able to determine the equation of a circle where the center is not at the origin. This is the equation of the circle that you must be able to determine here. You must write down the equation of the circle in the form. So you must be able to write the equation of the circle in this form by completing the square, and also write the coordinates of the center using the length and the length and the length of the radius. So you must be able to find the length of this radius, coordinates of the center, which is A and B. Right. Number 15, you must be able to determine the equation of the tangent to a circle. Remember, tangent to a circle, it touches the circle at only one point. This is straight line, so you must be able to find that equation in the form of y is equals to mx plus c. We must be able to determine the length of the tangent to a circle. So here we're going to find the length of a tangent to a circle. In most cases, we're going to utilize the distance formula. Number 17, we must understand the relationship between the circle and a point, and whether the point lies outside or inside, or outside or at the circumference of the circle. You must be able to understand the relationship between the circle and a line, whether the line is a secant, a tangent, or an exterior line. You must be able to understand the relationship between two circles, whereas the circles, they do not touch, whether they touch on 2 points, they touch externally, internally, or they are concentric. Right. Now, grade 12, let us now focus our attention to question 3 after we went through our checklist and we have confirmed that we have acquired the mastery of those concepts that are required under analytical geometry. And for this question, grade 12, I will give you 7 minutes to complete from 3.1 to 3.4. And your 7 minutes starts now. Welcome back, grade 12. Let us now look at question 3. Question 3 is as follows. In the diagram below, triangle ABCD has vertices A, D were given the coordinates as 3 and -9, and C, which is were given C as -9 and 0, where A is a point on the second quadrant, and B we have given B as, so the coordinates of B here, they're going to be -1 as to K, and this lies on the side of DC. So we're given those points, and you can see all of these points are represented. We have A there, we have a C with coordinates B and D, and we have our triangle drawn there. 3.1 says calculate the gradient of DC. Now to calculate the gradient of DC, so we are given DC. To find the gradient of DC, we are going to copy down the gradient formula to say M is equals to y2 minus y1 over x2 minus x1. And y2 is going to be negative 9. So this is y2 minus y1. Y1 is going to be the one on C, which is 0, all over x2. The x value of D is 3, so 3 minus x1, which is C, which is negative 9, and MDC is going to be negative 3 over 4. Right, let's proceed to 3.2. 3.2 says determine the equation of DC in the form of y is equals to mx plus c. Remember on D already, or on DC, we already have the gradient of DC, so we know that our gradient here, MDC, we found it from the previous question, was negative 3 over 4. Now to find the equation of DC, which is that straight line, we're going to say in the form of y equals to mx plus c, we're going to use the formula that says y minus y1 is equals to m into x minus x1. And we are going to substitute any point that line DC passes. So the line DC, that is the line that I'm working with. So I can only either substitute D or C. We are going to get the same equation. So I'm going to substitute maybe C in this case. I'm just going to say through C. Any point that lies on DC, either C, B, or D. So B can work because we have an unknown, but we can work with D or C. So when I substitute in my C, coordinates of C, y is equals to 0. So when there's y1, I'll place in my 0. It's equals to y minus y1, which is 0, equals to m. Our MDC we found in 3.1 was negative 3 over 4 into x minus our x1 here. So this is the x value of C, which is negative 9. And then we are going to now find y minus y0 is going to just be y. It's equals to negative 3 over 4 into negative multiplied by negative, we get positive. So it's x plus 9. Then when we simplify, we get our equation as y is equals to negative 3 over 4 x minus 27 over 4. Right, let's proceed. Now 3.3, it says show that k is equals to negative 6. How do we show that k equals to negative 6? We can see that k, it is found on B, and the coordinates of B, or point B, lies on DC. So we already have the equation of DC from the previous question. So we can just substitute from the equation of DC. So this was our DC from previous question. We are going to substitute the coordinates of B. So substitute B, which is coordinates of B is negative 1 and K. So remember, we found that our coordinates of B, it was given as negative 1 and K, and that K, it is the y coordinates of B. So we're going to say where there is X, I put in negative 1 because this is X is to Y. So my X is negative 1, and my K, it is going to be Y. So my Y here, which is K in that case. Then punch everything in a calculator, our K, we find it as negative 6. Right. 3.4, it says calculate the length of DC. To find the length of DC, we are going to use the distance formula. We are going to copy down the distance formula from the formula sheet. So we know that our distance formula is D, we have a root of x2 minus x1 all squared plus y2 minus y1 all squared. Then you're going to substitute in the values. Then we know that when we're saying x2, we can just take the x value of t there. So we're going to say x2, which is d, is going to be 3 minus x1, which is negative 9 all squared plus y2 is negative 9 minus 0 all squared. So we can now see that negative and negative will multiply, will get positive. In that case, it's 3 plus 9 all squared plus negative 9 minus 0. Then you punch everything in a calculator here. We get DC, which is 15 units. Right, grade 12, let us move on to our question 3.6 and question 3.5. So from 3.5 to 3.6 again. And for these two questions, grade 12, I will give you 6 minutes to complete those two activities. So I'm just fixing this part. So your 6 minutes start now. Welcome back, returns. Let us look at question 3.5. 3.5 says calculate the ratio of dB over dC. So to find the ratio of dB over dC, so this is just simply saying we just need to know the ratio of the two. Just have to find a distance of dB over the distance of dC. So the length of dB over the length of dC. So we just have to find that in terms of ratio. We have dC already. So dC, remember, it was 15. Then we need to find what is dB. We're going to use the distance formula where we are working between D and B. Remember, B, it is -1 and -6, as we have found from the previous questions. Then we just find the distance of dB. So dB is going to be 5 units. Then to find the ratio, remember dC was 15 units. So the ratio, which is dB over dC, is equals to dB is 5. So where there's dB, I place in 5. Where there's dC, I place in 15. So it's 5 over 15, which is 1 over 3. 3.6. 3.6 is as follows. M is a point on AD. So M, it is a point around AD such that AC is parallel to MB. Calculate the ratio of area of triangle MBD all over the area of triangle ACD. So what is the first thing that we notice here? We were told that M, it is a point on AD. So M, it is somewhere on AD. So I'm not going to pick that point. And we're going to, let's say, we're going to join those two lines. So this is M in that case, right? And they say such that AC, it is parallel to MB. So they're saying those two lines are parallel. So we are supposed to calculate the ratio of triangle MBD, which is this smaller triangle there, all over the area of ACD. Now to find those areas, we need to now remember that dB over dC was 1 over 3. And you notice that dm over dA, it will also be 1 over 3. Why? We are working with proportionality here. So we see that my dB over dC already, the ratio between them, it was 1 over 3. So the ratio between was 1 over 3. So this is going to be maybe 1x and this is going to be 3x in that case, right? So if that's the case, the ratios are the same. So meaning again, if the ratio between this is 1 over 3 of DC is 2 over dB over DC is 1 over 3, then the ratio of dA, so we need to follow the same pattern, all over dA, they will be equal because of proportionality. We have parallel lines. We are told that AC is parallel to MB. So because of proportionality, the ratios are equal. So this is analytical geometry. You don't need to write down the reasons, but here this was it was according to proportionality there, right? So we're going to use that proportionality theorem. So we can now see that the area of MBD, it is of triangle MBD over ACD, is equal to half is 1 over 2 of dm. So that is our dm all over dB to the sine of d. So we are using that angle d there, so to work with those areas. So we are working with that area there. Remember, we have m here, so to this side here in this case. So we're going to take this side and this side for the smaller triangle, and for the bigger triangle we are going to now say 1 over 2 dA. So we're going to take for the bigger triangle, we're taking those two sides, which is dA and DC, multiplied by DC and the sine of d again. So we're working with the same angle there because d is a common angle. So what we see here, 1 over 2 and 1 over 2 will divide out, then d and d will divide out. So what are we going to remain here? We're going to remain with dm over dA multiplied by dB over dC. This is what we are remaining with in this case. But remember, we said dm over dm is equal to dB over dC, right? So this is simply, they have the same ratios, 1 over 3 multiply by the 1 over 3 because those ratios are the same because we have parallel lines them. Then the answer is going to be 1 over 9. Right. Now, let us look at 3.7 quadrats. And for the 3.7 quadrats, you are given 8 minutes to complete 3.7. And your 8 minutes starts now. Welcome back, grade 12. Let us look at 3.7. 3.7 reads as follows. It is further given that the gradient of AD is negative 4 and the length of AD is 612 units. Calculate the coordinates of A. Let's proceed to this question. So we are told that the gradient here of this line M, it is negative 4, right? And we are given the length. So the distance of AD, it was given as 612 units. Then we are supposed to calculate the coordinates of A. So we are going to use those 2 points to find the coordinates of A. And our coordinates of A, it is X is to Y, because we don't know those coordinates yet. Right. Now, how are we going to work around this question? We are given the distance. So obviously, we are going to work with the distance formula. Remember, in my distance formula, I have Y in that case. And we're not going to be able to calculate easily if we are having Y. Why? Because the coordinates of A, it is X and Y. So we must have these two coordinates in terms of the same variable. So as to apply this distance formula and be able to find those coordinates. So in this case, we can either have them as X and Y and Y. So we need to find a way that we can represent Y in terms of X. So how can we do that? So that we can be able to apply this inside of our distance formula. So the first thing that I can do in this case, I can work with the equation of dA because I already have the gradient. So I can find the equation of dA. Then I'm going to substitute maybe the equation into, because this is y, so I can substitute the y into coordinates of A. So this is what I mean. I I will find the equation of dA, and my equation of dA, I'm going to say it is going to pass through D. So I'm going to substitute D is 3 and negative 9, and MAD we're told already it was negative 4. Then in my equation I have y minus into the y value of D, which is negative 9, is equals to M, which is the gradient, into x minus 3. Then our equation equals to y is equals to negative 4x plus 3. And I can now see that in the space of y here, I can now have my coordinates of A as x is, instead of y, I'm going to say negative 4x plus 3. Why? Remember, all these coordinates can be found by the same, the coordinates of A and B, they can be found by the same equation in this case, because A and D lie on that line, and the equation is negative 4x plus 3. So now I have coordinates of A in the same variable. So what I can do is I can utilize my distance formula to say AD, because I'm given distance squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Remember, this was square root. So what we did is to square both sides. Then the square root was resolved out. Then I can now substitute my values to say AD squared, it was 612. So I'm going to say 612 all squared in this case. It's equals to x minus 3 all squared plus y plus 9. Right. So this is what I'm going to have in this case. Right. So this is, I'm going to just introduce the square root here, so that I can just square that part of AD in this case. Right. Then we're going to say, we're going to substitute in our values and say, okay, the square root of this is going to subtract to resolve out. We are going to have 612. It's equals to x minus 3. Then the y value of it is no longer y, is going to be negative 4x plus 3 plus 9. So that's what I'm going to have for this bracket right here. So that is where I am having, that is my y value of a in that case, right? So then I'm going to solve this. So when I solve, I'm going to simplify here, and I'm going to remain with negative 4x plus 12 all squared. Then I'm going to do what? I'm going to just repeat this part where I'm going to remain with x squared minus 6x plus 9 plus into, then I'm going to solve the second part. I'm going to have 16x squared plus minus 9x plus 144 is equal to 612. Then here I'm going to collect my like terms. I solve this equation. I'm going to remain with 17x squared minus 102x minus 459 equals to 0. Then when I divide by 17 throughout, because 17 is common, I can divide by 8. I will remain with x squared minus 6x minus 27. I can factorize what is on my left hand side, and I will have x plus 3, and I will have the second bracket as x minus 9. Then x equals to negative 3, or x equals to 9. But 9x cannot be 9 in that case, because a, it is found on the second quadrant and a is negative. X coordinate of a there is negative, so x can be negative 3. Now, how do we find the y coordinate? You can just substitute x equals to 3 and y equals to negative 4x plus 3. Then my corresponding y value, because this is the equation of a, so we can find the y value of t as we have the x value of in this case, right? Then I'm going to substitute x is equals to negative 3. So we're going to have negative 3 then my y is going to be 15. So this is going to be negative 4 times 3. Negative 3 is going to be positive 12 plus 3. So this was a typing error then. Then my y goes to be 15. Right, then the coordinates of a is going to be negative 3 and 15. Right, grade 12, let us move on to question 4. So for question 4, grade 12, we have question 4.1 to 4.3. And for these three questions, I am giving you 5 minutes, or not 5 minutes, I'm giving you 10 minutes to complete 4.1 to 4.3. And your 10 minutes start now. Welcome back, grade 12. Let us look at question 4. Question 4 is as follows. In the diagram, the coordinates of M are 1 and 3, and this is M is the center of the circle, so M is the center of that circle, and the circle has the x-axis at N, right? ST is the tangent to the circle at P, right? So ST, we are told that it is the tangent at P, and R, the coordinates of R are D and 1, so we have R which is D and 1, with this greater than 0, and L lie on the circle. O and V are the x-intercept of PL and RL respectively. Write down the coordinates of L. So where is L in this case? So we are given L at that point, and to find the coordinates of L, here we are going to have our coordinates of L as negative 1 and negative 3. So here, to find those coordinates of L, we can make use of our midpoint formula to find the coordinates of L. So this becomes very easy. So what we can simply do is the following. We can now say midpoint of L, remember, it's going to be x1 plus x2 over 2 is to y1 plus y2 over 2. So I'm going to find the x coordinate first. I will just say my x coordinate of L. So the midpoint of L in this, midpoint of PL in this case is M. So this is the midpoint is M. So the x coordinate of M in this case is going to be how much? X coordinate of M is 1. It's equals to x1. So x1 is the x value of P. So I can say this is P, and L, this is P and L. So this is 1 is equals to x coordinate of P. It is 3 plus x coordinate of L over 2. Then I can solve for x here. So when I solve for x, what do I get? I get 2 times 1, which is 2. So I have 3 plus x coordinate of L is equals to 2. Then XL is going to be 3 minus, or 2 minus 3. Then XL is equals to be -1. Right, and I can proceed again, use the midpoint formula again to find the corresponding y value in this case. Now, to find the corresponding y value, what I can do is I can just say yp plus yl over 2 is equals to a y value of m. Remember, m is the one that is the midpoint in this case. Right, so this is the midpoint, which is m. Then yp is 9 plus yl, which is what I'm looking for, over 2 is equals to ym, which is 3. So 3 times 2 is equals to be 6. It's 9 plus yl is equals to 6. Then y is going to be 9 minus, or 6 minus 9, which is how much in this case? This is going to be -3. Right, or we can just find this one using our transformation here. How can we find this L by transformation? Because they just write down. So to find it by transformation, we know that x value was, so we move from 3 to 1 in this case. So in terms of values, x values, so 3, we had 1, and the second x value here was 3. So how many units did I move from 3 to 1? So it's 1, 2 in that case. Then how many units must I move to move from m to l? Because m was the midpoint, so I must also move 2 units going down. So I'm going to say 1 unit is going to be 0, and the second unit is going to be -1. So that is the transformation in terms of x-axis. So that's why L is going to be -1 when I transform them. Then to find the corresponding y value by transformation again, I just have to find out how did I move from these 2 points, because m is the midpoint. So y is 9 here, and y it is 3 here. So how many units did I move down to get to how much? To get to 3. So because it's m is the midpoint, I'm going to say 1, 2. So let's just count how many units it's going to be, just to make it easy. From 9 to 3 is going to be around 6. Is 9, 8, 7, 6, 5, 4, 3. So how many units are those? Is 1, 2, 3, 4, 5, 6. So I moved 6 units here. So I can just say 3 minus 6. Then I'm going to get -3. So, but let's just wait. So we're going to move 6 units again to go down here. So to go down to L, because M is the midpoint, so I'm going to say it's negative, or it's 2, 1, 0, 1, 2, 3. So I move 3 there. Then -1, -2, -3. So that is where I'm going to get my -3 using that transformation. Right, let's proceed. 4.3 is written as follows. Determine the equation of the tangent st to the circle at P. So we're looking for the equation of this line, which is our tangent, which is y equals to mx plus c, which is a straight line. So the first thing that we're going to do to find the equation of the tangent, it is to find the gradient, which is m in this case. But now to find the gradient of this one, we need to find the gradient of this one. So we're going to invite a bit of Euclidean geometry here to work around this question. Remember, the tangent is perpendicular to a radius. So tangent is perpendicular to a radius. So the gradient of PM is multiplied by the gradient of this is going to be -1. So the first thing that I'm going to do, I have to find the gradient of MP. So the gradient of MP is going to be 3. So I find the gradient of MP because I have coordinates of P and coordinates of M. We couldn't find the gradient of HT straight because we don't have 2 coordinates, only have 1 coordinate. So coordinate of MP is going, the gradient of MP, it is going to be 3. So MMP is going to be 3. Then I'm going to say MHT multiplied by MMP equals to -1. Why? This is analytical. You don't have to write the reason down, but this one we can say we stole it nicely from our Euclidean. Is tangent perpendicular to a radius. Then we know that the ST is going to be what? -1/3. How so? So it's MST. It's multiplied by m and p was multiplied by 3 equals to -1. So I divide by 3, then mst equals to -1/3. So I have already mst, so that I found the gradient of st. Now to find the whole equation, or to find c, I'm going to say y minus y1 is equals to m into x minus x1. Then I'm going to substitute a point that is on st. The only point that I have on st is p, which is 3 and 9. So I'm going to substitute 3 and 9 in the equation so that I can find my equation of a straight line. Remember, our m, it was 1/3. Then the y is going to be -9. So it's y minus, into -9. It's equals to -1/3 into x minus 3 in this case. Then y plus 9 is equals to, solve what is on the right hand side, equals to -1/3 plus 9. Then we're going to now have y in this case. Our y is going to, the 9 is positive here, it's not negative, so this is correct here. So this is y minus 9. Then you transpose the 9 here, is going to be plus 9. Then you get y equals to -1/3 plus 10. Now let's go to, move on to question 4.3. And for 4.3, grade 12, let us go through it. It says, show that the equation to a circle centered with m is x squared plus y squared minus 2x minus 6y minus 30. So already our equation of a circle is found as y x minus a all squared plus y minus b all squared is equals to r squared. Then we're going to substitute the center. Our center is m. So remember, our center m, it is a is to b. Then the value of a is 1 and the value of b, it is 3. Then that is our equation of a circle. Then, but to complete the equation of a circle, we need to find r. To find r, we substitute any point that lies on the circle. So any point that I'm going to substitute here is going to be p, because r, we have an unknown there, l, we don't even have the coordinates. Then we're going to substitute. So here we're going to substitute p, which is now 3 and 9. So where there's x, I place in my 3. Where there's y, I place in 9. Then my r squared is going to be 40. Then I'm going to represent this equation with our r squared there. Then our equation is going to be x minus 1 all squared plus y minus 3 all squared is equal to 40. Then I can now simplify this side. I can distribute the first bracket. I'm going to get x squared minus 2x plus 1. Then when I simplify or I expand the second bracket, I will get y squared minus 6y plus 9. Then all is equals to 40. Then I can simplify here by collecting the like terms. Then I get my equation as x squared plus y squared minus 2x minus 6y minus 30. Now let us see how we simplified this. So the like terms here we're going to have is, we have x squared minus 2x plus 1 plus y squared minus 6y plus 9 minus 40. So what we're going to have there is x squared. There's no like term of x squared, and there's y squared again. Then 2x remains as 2x, 6y remains as 6y. And 1 plus 9, which is 10. Then we have 10 this side, and 10 minus 40. As we transpose the 40 there, or you apply the additive inverse of that, it's going to be 10 minus 40 is going to be negative 30. And this is how we've shown that the equation can be represented like that. Now, grade 12, let us move on to 4.4 to 4.6. And for these 3 questions, grade 12, I will give you 10 minutes to complete these 3 questions. And your 10 minutes starts now. Welcome back, grade 12. Let us look at 4.4. Now 4.4 reads as follows. Show that d is equals to 7. Now remember, d, it is a x coordinate of r, and this x coordinate of r, it lies on the circle. And we already have the equation of the circle from the previous question. Then we can now take that equation of the circle. We are going to substitute the coordinates of r, which is the x value of r is d, and the y value of r is 1. So where there is x, I will place in my D, where there's Y, I will place in my 1. Then I'm going to substitute those values. X is this, so it's going to be D minus 1 all squared. Then Y is 1 minus 3 all squared is equals to 40. Then I can just simplify there. So we're going to get D minus 1 all squared. Then 1 minus 3 is so we're going to have 1 minus 3, which is 2. 2 squared is going to give us 4. Is equals to 40. Then you can now apply the additive inverse of 40. Then we're going to have minus 4 here. Then we're going to have 36. So D minus 1 all squared equals 36. What I can do here to solve this, I can introduce the square root both sides, which is plus or minus, or I can do what? I can now distribute this into D minus 1 is equals to 6, or in that case. So what I can say is I'm going to say D minus 1 all squared is equals to plus minus the root of 36. And this is just, we apply the square root both sides so that we can get rid of the square. And we are going to have D minus 1 is equals to plus minus 6. So D minus 1 equals to 6, or D minus 1 equals to negative 6. Then D equals to 7, or D equals to negative 5. Now we can say that D, it is in the first quadrant, and which is X. So this value must be positive. So D must be 7 in this case. So therefore D is 7 because it is on the positive side. Now let's proceed to 4.5. 4.5 says calculate the size of L. So L, we are looking for that angle right there. Now to find that angle of L, so we need to work with the angles of inclination here. So the first thing that I'm going to do is I am going to work around this angle here and see how much is that angle. And remember, I've already found the gradient of MP. MP, gradient of it was 3, so it was given as stream. Then to find this angle right here, what I'm going to say 10 POV. So this is 10 POV, which is that angle, it is equals to 3. So this is the formula that says 10 theta equals to M, right? Then I can find this one to say my POV is equals to the second function of 10, 3, then which is now 71,56. So this one is 71,56, right? Then I can proceed and find this angle right here, so which is RVL. To find that, I need to find the gradient of RL first. Now to find the gradient of RL, in this case, remember I have the coordinates of L now, right? So remember my coordinates of L was -1 is to -3. So the gradient of RL is going to be 1/2. Now to find this angle of inclination, which is RVN, I'm going to say tan RVN equals to 1/2 using that formula. Then I'm going to find RVN. My RVN is going to be 26,6. So this is 26,6. Just write it clear so you can say it. So it's 26,6 degrees. Right. Now what I do also see is the following. RVN, it is also equals to LVO. These two angles are equal. Why? Because those are the vertical opposite angles. You didn't have to write the reason down, but I just wrote it so that you can understand what is the reason here. So this is also 26,6 degrees. Right. As we proceed, then we realize that POV, this angle, which is the exterior angle, it is equals to angle L plus LVO. So it's equals to these two angles. Let me just mark them with a red marker there. So this angle, which is an exterior angle, is equals to the sum of this angle and that angle right there, which is angle L plus LVO, which is an exterior angle of a triangle. Then the exterior angle of a triangle, we are working with POV. POV was 71,565. Is equals to L plus 26,565. Then my L is going to be, we're going to just subtract 26,565 both sides. Then L is going to be 45. That's how we find the size of L. Right. 4.6 grade 12. Let us go through 4.6. 4.6 says TR, it is a tangent to the circle at R. Okay. So there is a tangent here. So this line TR, it is a tangent at that point. Prove that PT, so we need to prove that PT, it is perpendicular to RT. So we need to prove that these two are perpendicular. Right, to prove that the two are perpendicular, we need to work with their gradient. And we remember we have the gradient of ST, as we have found the equation of ST. So what we need is to find the gradient of RT. So to prove this, we will need to say MPT. When I multiply it with MRT, I must get -1. So those are the perpendicular lines. So to find RT, we know that we don't have the coordinate of T in this case, so we cannot find the gradient directly here. But we can invite our Euclidean geometry here and find the coordinates of, so we have a coordinates of R. So we already have the coordinates, we don't have to find them again. We have to find the gradient of Rm. If I can find the gradient of Rm, and we know that a tangent is perpendicular to radius, then I can find the coordinates of Rt. So the coordinates of Rm was -1/3. Then to find the coordinates of Rt, I'm going to say Mrt multiplied by Mrn. M is equal to -1. Why? Tangent perpendicular to radius, because we're told that it's a tangent here. Then Mrt is going to be 3. Remember, this was MRT multiplied by -1/3 is equal to -1. So I multiply by -3/1, multiply by -3/1. Then I got -1 multiplied by -3/1. We got that to be +3. So we have MRT, and we know that MPT, we found it from the previous question. It was also -1/3 from our equation of that straight line that we found there. Right, then we can say when you multiply them, MRT multiplied by MPT, which is 3 multiplied by -1/3, we get the answer is -1. So because when I multiply the gradients of these two, I got a negative answer according to this, then we can conclude that PT is perpendicular to RT, because when you multiply their gradient, we are getting a -1 as a final answer. Right, grade 12, that brings us to the end of our lesson. Please join us again for our next lesson. For our next lesson, we are focusing on mathematics paper 2 revision. We are focusing on the second part of our revision, and we will be looking at trigonometry. Trigonometry for November 2024, we are going to look at question 5, question 6, and question 7, including question 8. Thank you. Enjoy the rest of the day. See you on the next lesson.